Alright, so today we're going to look at section 4.2, which we're continuing to work with rational functions. We're going to continue graphing them, but they're going to get a little more intense today. So, first off, we have the definition of a rational function. Really, like today, we're going to have a polynomial over another polynomial, so things are going to get intense. Our domain is the big takeaway from this box. It is going to be the set of all values of x. We have all real numbers except the x values that make our denominator go to 0. Okay, so our domain is always all real numbers except whatever x number makes our denominator go to 0. A couple other key concepts here. We have x-intercepts. You already know what an x-intercept is. It's where the graph crosses the x-axis. The big takeaway for this is that your x-intercept goes with the numerator. Okay, so x-intercepts go with the numerator. You take your numerator, set it equal to 0, and then solve. You may need a factor to do that. Our vertical asymptote are going to be whatever sets the denominator, or whatever makes the denominator equal 0. Takeaway on this, denominator. Okay, so x-intercept is numerator, vertical asymptote, denominator. Horizontal asymptote, you're going to have two scenarios here. You have it when the degrees are the same. We compare the ratio of the leading coefficients. Okay, so same degree means we're dealing with leading coefficients. If the denominator has a larger degree, which is the style that we had in 4.1, then you're going to have y equals 0. And then our last one, for y-intercept, you plug in 0 wherever there's an x, and then whatever's left over, that's your y-intercept. So looking at example 1, they ask us to find all these key pieces of information and then graph it. Okay? So with this, example 1, they want you to consider the function g of x equals 4x over x minus 3 and find the requested information. So first step, x-intercept. So our x-intercept is the numerator. And it's not just the numerator. You take the numerator and set it equal to 0. So I'm going to do it over here in red. Our numerator is 4x. I set it equal to 0. I solve. I get x equals 0. Now, we want to write the intercept as an ordered pair because that's what it is. It's a point. And as soon as we have that point, we're going to throw it on our graph. Okay, so I have a dot at 0, 0. The next thing we want to find is the y-intercept. So for the y-intercept, and I'm going to do that in blue, you plug in 0 wherever we see an x. So for this one, when I work it out, I get a y-intercept of 0. And again, it's an ordered pair, or it's a point, so I want to write it as an ordered pair. Go ahead, put that dot on our graph. We already had one at 0, 0, so it's just going to overlap. Next thing they ask for is the vertical asymptote. From up above, we know the vertical asymptote deals with the denominator. So we're going to take our denominator, I'm going to do this in green, and set it equal to 0. So x minus 3 equals 0. Our asymptote is going to be x equals 3. Remember, the asymptote is a line, so we need to make sure that we have an equation for a line. X equals 3 is a vertical line. So we have a dotted line going through x equals 3. You need to include that line on your graph. If you do not include your asymptotes, it's wrong. Horizontal asymptote, that's where we have our two scenarios. So if they're the same or different, we do different things. In this case, both my degrees are the same. So in black, I'm going to circle my leading coefficients. We got 4 and 1. So we're going to have a horizontal asymptote at 4 divided by 1 is just 4. Okay, so when your degree is the same, you go ahead and take your leading coefficients and divide them. So I have a horizontal line at 1, 2, 3, y equals 4. Draw it in, label it. Okay, the last two things we need to answer here are domain and range. If I ask you for the domain and range, we always start off with all real numbers. For domain, it's going to be x can't equal whatever my vertical asymptote is. So in this case, I have a vertical asymptote of 3. My domain is all reals. X cannot equal 3. For our range, we start off with all reals, and then y cannot equal 4. Now, as far as this class is concerned, your range is going to work out that way every single time. Okay, so it's going to be all reals, y cannot equal the horizontal. Realize, though, when you go on to pre-calc and higher levels of math, that's not always the case with the range. Sometimes weird stuff happens with the range, but for this class, we're fine. Okay, we're just matched up with the horizontal asymptote. All right, so that takes care of example 1. Like we've been doing, I need you to do the 2 try-its on page 10 on your own. Okay, so now for example 2, 2A, we get a little more intense here. Okay, if you notice, like I have like a legit trinomial up top, trinomial down below, so we got to do a little more work. Also notice I changed the example to be 3x squared plus 7x plus 2, and then that is still over our x squared minus 2x minus 8. Okay, so I changed the numerator on this problem. Okay, for this, you really need to break it down and remember that x-intercept is numerator. So what we do is we take our numerator, 3x squared plus 7x plus 2, and set it equal to 0. We go ahead and factor that. It's going to factor down to be 3x plus 1, x plus 2. And then solving each of those is going to give me intercepts at negative 1/3, okay, because I minus 1 divided by 3, and negative 2. And then remember, these are points, so I want to write them as ordered pairs. So we got negative 1/3, 0, get negative 2, 0. The y-intercept I'm going to go ahead and do in red. Remember, for the y-intercept, you plug in 0 for x. So I look at my original function. If I go ahead and plug in 0 for x, it gets rid of all those terms. So we are just left with 2 over negative 8. Which simplifies down to negative 1/4. We want that as an ordered pair, so it's going to be 0, comma, negative 1/4. Vertical asymptote, remember, it goes with denominator. So we take our denominator, x squared minus 2x minus 8, set it equal to 0. So we get x minus 4. X plus 2 equals 0. We solve and get x equals 4, x equals negative 2. Remember, an asymptote is a line, so you need equations, and we have the equations. So I go ahead and just put x equals negative 4, x equals negative 2. Those would be my dotted lines going up and down. The last thing we're asked to find is the horizontal asymptote. So remember, for horizontal asymptotes, we look at our degrees. If the degrees are the same, which they are for this problem, you take your leading coefficients and divide them. So in this case, my leading coefficients for the problem that I created are 3 and 1. So we have a horizontal asymptote at y equals 3 over 1, or just y equals 3. Okay, so I need you to go ahead and try example B on your own. Okay, so that'll be the try it for example 2. Then take a picture and submit it to the Google Classroom.